And I'm Abel. Welcome to everyone. This is our Lecdem channel to enhance your knowledge. Today's topic is about cardiac cycle. The sequence of coordinated events taking place in heart from one heartbeat to the next is called cardiac cycle. Cardiac cycle includes both electrical and mechanical events. The electrical system of the heart includes the sinus node, which is also known as the natural pacemaker of the heart, which is able to produce its action potential due to the presence of leaky sodium channel. This action potential then reaches the AV node and then further reaches the bundle of His, and where it gets divided into left bundle branch and the right bundle branch and then reaches the Purkinje fibers. Electrical events precede and initiate the corresponding mechanical events. Events in the cardiac cycle. So it includes the atrial systole and the atrial diastole, and along with the ventricular systole and the ventricular diastole. So we are going to begin the cardiac cycle with atrial contraction, followed by ventricular contraction, and followed by ventricular filling, that is ventricular diastole. Duration of the events. The total duration of one cycle is 0.8 seconds. So the atrial systole lasts up to 0.1 second, and atrial diastole for 0.7 seconds, and ventricular systole for 0.3 seconds, and ventricular diastole for 0.5 seconds. Other events are as follows. So the atrial systole for 0.1 second and ventricular systole has been further divided into isovolumetric contraction, which lasts up to 0.05 seconds, rapid ejection that lasts up to 0.11 second, and slow ejection that lasts up to 0.11 second. That is ventricular diastole. So protodiastole for 0.04 seconds, isovolumetric relaxation that lasts up to 0.08 seconds, and rapid filling for 0.11 second, and slow filling also known as diastasis for 0.19 seconds, and last rapid filling phase or the atrial systolic phase which lasts up to 0.1 second. Atrial systole, that is atrial contraction. During a period of ventricular relaxation, that is ventricular diastole, blood flows from the atria to the ventricles. About 75% of blood flows to the ventricles before the atria contract, and then both the atria contract simultaneously and pump the remaining 25% of the blood into their respective ventricles. So this contraction in atria increases the pressure inside the atria, that is about 4 to 6 mmHg in the right atrium and up to 7 to 8 mmHg in the left atrium. Then there is a period of atrial diastole, that is atrial relaxation, that is filling of blood to the atrium by the veins. For the rest of the cardiac cycle, during which various ventricular events occurs in the sequence as follows. Ventricular systole. So now the atrium has emptied blood into the ventricles. So now the ventricular contraction is to begin. At the termination of atrial systole, the pressure of the blood in the ventricle rises. Rising ventricular pressure now exceeds the atrial pressure. This causes the closure of atrioventricular valves, that is the mitral and the tricuspid valves, which is a major component responsible for generating the first heart sound. Isovolumetric contraction. So iso means same volume of blood remains in the ventricle. At the beginning of this phase, the AV valves are closed and the semilunar valves, that is the aortic and the pulmonary valves, are not yet opened. Thus, the ventricular chambers are sealed from both the arteries and the atria. The ventricles start contracting, but the volume of blood inside both the ventricles remains the same. So, this isovolumetric contraction phase lasts up to 0.05 seconds. During this phase, ventricles contract as a closed chamber and the pressure inside the ventricles rises rapidly to a higher value. When the LV pressure increases up to 80 mmHg and the RV pressure is slightly above 8 mmHg, the ventricular pressure pushes the semilunar valves open. This causes ejection of blood from ventricles to the respective arteries in the next phases. Rapid ejection. As the increased ventricular pressure has caused the semilunar valves to open, now the blood gets rapidly ejected into the arteries. which are going to be discussed now. As soon as the seminular valves are open, the blood is rapidly ejected. About two-thirds of the stroke volume is ejected in this rapid ejection phase. This phase lasts up to 0.11 second. So the LV pressure rises up to 120 mmHg during this rapid ejection phase. RV ejection begins before LV and continues even after the LV pressure is completed, as both ventricles eject same volume of blood. Slow ejection. Now the ejection rate will be decreased during this phase. During the later two-thirds of the systolic rate of ejection declines. During the period of slow ejection, rest of the volume, that is a one-third of the stroke volume, is being ejected into the arteries. During the period of slow ejection, ventricular pressure falls to a slightly lower value than the aorta. But still, the blood continues to empty into the aorta because the blood flowing out has built up momentum. As this momentum decreases, aortic pressure rises slightly above that of the left ventricle. So until now, the atrial contraction has been completed. So during the period of atrial contraction, the atria empties blood into the ventricles. Then follows the ventricular contraction, during which the ventricles contract and pushes the blood through the respective arteries. Then follows the ventricular diastole. So the first phase of ventricular diastole is the protodiastole. At the end of ventricular systole, ventricles start relaxing, allowing rapid fall in the intraventricular pressures. At this end of phase, the elevated pressure in the aorta and the pulmonary artery immediately pushes the blood back towards the ventricle, which snaps the aortic and the pulmonary valves close. So this is a major component in generating the second heart sound, isovolumetric relaxation. So the ventricle continues to relax as a closed chamber, as the semilunar valves, that is the aortic and the pulmonary artery, are closed, and the AV valves, that is the mitral and tricuspid valves, are not yet opened. This causes rapid fall of pressure inside the ventricles. When the ventricular pressure falls below than the atrial pressure, the AV valves open. Rapid filling. During ventricular systole, that is contraction period of the ventricle, because AV valves, that is the mitral and the tricuspid valves, are closed, large amount of blood accumulates in the atria. Since the veins continue to empty the blood into them, that is, the SVC and the IVC empties blood into the right atrium and the pulmonary veins empty blood into the left atrium. So this causes an increase in pressure inside the atria. High atrial pressure causes the blood to flow rapidly into the ventricles. Then the pressure in both the chamber falls as the ventricular relaxation continues. Slow filling or the diastasis. After the rapid filling phase, pressure in the atria and the ventricle rises slowly. As the blood continues to return to the heart, this decreases the rate of blood flow from the atria to the ventricle, causing slow filling of the ventricle, known as the diastasis. During rapid filling phase and the diastasis phase, about 75% of blood passes from the atria to the ventricles. Then the next cycle begins with atrial systole. Thank you.